Welcome to the Simply Financial Podcast. I'm your host, Christopher Calandra. This episode is the first of a three-part series we are calling The Science of Money. This episode, I will talk about money math. Part 2 will cover financial experimentation. And then the final episode, Part 3 in the series, will be the psychology of money. The goal of this three-part series is to educate you, the listener, on some key financial concepts, but also want to demonstrate similarities the financial planning process has to science, in particular, the scientific method. So if you're listening to this, please know that I am not a scientist, far, far from it. But the scientific method, very simply, is the process of observing, forming a hypothesis, making predictions, conducting experiments, and then analyzing results. This is very similar to many aspects of the financial planning work I do and the team does here at Elliott Wealth Management, where we try and help our clients achieve their financial goals. So today I want to cover 4 topics. The first is standard deviation. Then the 4% rule, want to cover compound interest. And then related to that is the rule of 72. These are examples of what I call money math. So the work that I do as a financial planner, we bring a lot of expertise to the table in terms of investing, portfolio construction, asset allocation, things like that. And standard deviation is a key risk metric because risk analysis is a really important part of what we do for clients. So let me give you an example. If I presented to you option number 1, an investment, could be anything, and I tell you that the return is 10%, and then I give you option 2, and option 2 also has a 10% rate of return, then I ask you which one would you want? Option 1 or option 2. Most people would say, Chris, it doesn't really matter. They both have the same rate of return. But the better answer, the one that we are solving for, is to select the option that took the least amount of risk to get to the 10% rate of return. That's a better answer because it's not just about return. Risk is a very important element. So let's go back to standard deviation. Think back to school, or maybe even the work you do if you're in the science field, and think of the bell curve. It's very closely related to standard deviation. And what the bell curve, if you could picture it, what the bell curve talks about is one standard deviation is 68% will fall into that range. When you go 2 standard deviations, the likelihood of being in the range is 95%. And if you go to 3 standard deviations, you go all the way up to a 99.7% likelihood of being in that range. So let me give you an example in the investment world. Let's say you have an investment, and again, I'm making this scenario up. It's meant to be educational. Is an investment with a 15% rate of return and a standard deviation of 10. So 15% return, 10% standard deviation. 68% of the time, the return will be in the range of plus or minus 10 of the 15% rate of return. So 68% of the time, you would expect that the return would fall between 5%, which is minus 10 of 15, or 25%, which is 15 plus the 10. When you go up to 2 standard deviations and you get up to a 95% likelihood that the investment return will be between negative 5% and 35%. Now, that's a pretty big range, but it does show you how spread out the data can be, and it gives you a really good perspective on what you might want to expect. As I said at the top of the show, I'm not a scientist, but my understanding is that science uses standard deviation to help analyze and interpret experiments and data in those experiments, helping to determine precision and accuracy of various measurements. It also helps with assessing the reliability of experiments. So there's a lot of overlap between my use of standard deviation in investments, portfolios, asset allocation. Let me point out that this standard deviation metric isn't only used for a single investment, like the answer I gave you or the illustration I gave you, but it's used to analyze portfolios. We could compare various portfolios, not just return wise, but risk wise. We can experiment with changing various inputs, swapping one investment out of a portfolio to another to analyze the results to see if we get some benefit, either risk wise or return wise. Which leads me to my last point, is that there is more sophistication that gets brought to the table with this. When you begin blending return metrics along with risk metrics, including standard deviation, you can do some really important work in helping clients establish portfolios and investment strategies. Next, let's talk about the 4% rule. This is a guideline that was introduced by a financial advisor, Bill Bengen, back in 1994, and it's a great rule of thumb. It is a method for calculating how much you can withdraw safely, and that's in air quotes, from your retirement savings each year without running out of money during your lifetime. So the rule of 4% suggests withdrawing 4% in the first year of retirement, or when you need to draw money from your nest egg. And then each year, adjust the 4% for inflation. It is a great and simple back of the envelope calculation. And this is an example of an experiment that was done back in 1994 or the years preceding that. That is research that my industry leans on heavily to help make portfolios and map out retirement income planning. So let's talk about how this works. To give you an example, if a client has a $2 million nest egg, you apply the 4% rule, that means a safe withdrawal rate in the first year would be $80,000. Keep in mind that this is not an absolute. It's called the 4% rule, but it's more of a rule of thumb, more of a guideline. It has its flaws, but it is nice because quickly and easily you could apply the rule and come up with some quick down and dirty numbers. Really works out well. The 4% rule was back tested, as I said, back in the early 1990s, and found that most of the time when you're investing 50% into the S&P 500 and 50% into intermediate government bonds, that the portfolios are able to generate that income for 50 years or longer without running out of money. There were some instances where it didn't make it to 50 years, and many of those lasted for 35 years or longer, which is enough time for the majority of retirees, thus the advent of the 4% rule. The thing about it is that the way that it works today, it's become a little bit of a shorthand rule, so that the work that the advisor did was that 50-50 allocation that I just shared with you, but it's meant generally as a description for any diversified portfolio that incorporates stocks and bonds into it. A very loose application of the 4% rule. Also, most times for simplistic purposes, they'll just assume 4% without the adjustment of inflation. Again, just because the math is easier, can be done in your head, or done on a paper and pen. We have some powerful software, which we'll talk about throughout this 3-part series, that puts more sophistication to the process. But it is a good rule that we use a lot. Let me point out quickly that there's the feature of this 4% rule. When you flip it, you could also use a 25 times 25 times formula to solve for different desired income. I know I tripped over my words there, but basically, if you said, I would like $100,000 of retirement income, how much money do I need in my nest egg? Well, I would take $100,000 times it by 25. That gives me 2.5 million. If then I apply the 4% rule, if you're following the math at home while you're listening to this, $2.5 million applying the 4% rule gets you to the $100,000. So I not only can use it to quickly figure out how much income might be able to safely be withdrawn from any pot of money, I could also do it in the inverse and say, how much income are we looking for? I could tell you roughly how much you need in your nest egg. Please note that this rule is not absolute. I did an episode on this subject back in season 6 of the Simply Financial podcast. It was episode 6. I did a deeper dive into the 4% rule, talking about how it could be used, but also talked about its flaws, kind of updating it for today's world. So please take a look at, listen to that if you want some more information on the 4% rule and our interpretation of how we use it and where it goes wrong. So now that we covered standard deviation and the 4% rule, I want to talk about compound interest. I want to start this section with a quote from Albert Einstein. He said, and I quote, "Compound interest is the eighth wonder of the world. He who understands it earns it. He who doesn't pays it." So this is a powerful quote. I learned of this quote when I was very young in the business, some 30 years ago. It's also a cautionary tale about debt and the negative aspects of being a borrower. We'll save that for a different conversation. But thinking about compound interest, it is when you earn interest not only on the money you originally invested, but your interest also earning interest. That means that the longer money is invested, the greater the potential for growth. And additionally, the higher the interest rate, the greater the growth. Compound interest is very powerful, as Albert Einstein referenced in his quote. It is simple, but it is very, very overlooked. A lot of people underestimate the power of compound interest. So a quick example, if I invest $1,000 and I get a 5% rate of return, after year one, I would have $1,050. I would have earned $50. If in the second year, I keep the money invested and I get the same 5% rate of return, my interest in the second year would be $52.50. My account would have grown to $1,102.50. So if you think about it, my $1,000 earned the same $50 in each of the 2 years. But in the second year, I get the benefit of the compounding. The interest from the first year, that $50 I earned in the first year, earns $2.50 also, making my return in the second year greater, in part because of the original interest, the original principal, but then also the interest. And if you just play that out, you could see that over time, the interest earning interest grows in sort of a snowballing effect. And if you stay at it long enough, your interest could be earning more interest than your original principal. And that is where the power of compound interest really starts to flex its muscles. My understanding is the concept of compounding is used in the field of science when calculating things like population growth, radioactive decay, and chemical reactions. Many scientific fields use compounding as it plays a crucial role in modeling and in predictions. Related to compounding, the last point I want to make in today's episode is the rule of 72. I talk about this at greater length in the Simply Financial podcast series season 6, episode number 40. It is a simple formula, sort of like we did with the 4% rule, that is for the calculating of compound interest. So the rule of 72 is as follows. If you take an interest rate and you divide it into 72, the answer gives you the number of years it takes money to double. So if you earn a 2% rate of return, which is low, although higher than banks recently had been paying. I know bank rates have come up here recently, but use 2%. You divide 2% into 72. The answer is 36. That means $1,000 invested or saved at a 2% interest rate would double to $2,000 in 36 years. Not very impressive with the compounding. But if we use a higher interest rate, let's assume a 9% interest rate, that means that money would double every 8 years. So that $1,000 in my example, in just a short 8 years, that $1,000 would be worth $2,000. And then in 16 years, that $2,000 would be worth $4,000. In 24 years, you would be up even further with the doubling. And as you play that out, you could see how the money would grow and that compound interest snowballs to have a very, very positive effect on your wealth and your nest egg. It's not exact. I mean, if you actually ran it out on the calculator, it's not down to the penny exact, but it's a great back of the envelope calculation that can be used as a great shorthand. I found in my experience, teaching the rule of 72 to people that I meet, especially younger individuals, is a great way for them to appreciate compound interest in a way that maybe they didn't before. It's just a great, useful tool. I really do love it. So that's the end of today's Money Math episode, which is the first in a 3-part series we're calling The Science of Money. Please, if you like the content, subscribe to the podcast, Simply Financial. I also want to point out that we've prepared a white paper, the 7 wealth building rules. If you want this, go to www.elliottwealth.com/wealth so that you could access the white paper. I think you'll find it to be very valuable and informative. So check it out. I will be back with you on the next episode of the Simply Financial podcast, where we will discuss financial experimentation. Thanks for listening today.
The views expressed are not necessarily the opinion of SagePoint Financial Incorporated and should not be construed directly or indirectly as an offer to buy or sell any securities mentioned herein. Investing is subject to risks, including loss of principal invested. Past performance is not a guarantee of future results. No strategy can assure a profit nor protect against loss. Please note that individual situations can vary. Therefore, the information should be relied upon when coordinated with individual professional advice. Please note, the information being provided is strictly as a courtesy. When you link to any of the websites provided here, you are leaving this website. We make no representation as to the completeness or accuracy of the information provided at these websites, nor is the company liable for any direct or indirect technical or system issues or any consequences arising out of your access to your use of third-party technologies, websites, information, and programs made available through this website. When you access one of these websites, you are leaving our website and assume total responsibility and risk for your use of the websites you are linking to. Securities and advisory services are offered through SagePoint Financial Incorporated, member FINRA SIPC. Insurance services offered through Elliott Wealth Management, LLC, not affiliated with SagePoint Financial.